Hey Josh, Jeff Barrows here. Let me see if I can help you out with this model problem on the golf problem. It looks like all the regression results are correct. So in order to come up with this model based on the first question here, it looks like you've got all the regression results correct. The only thing that you need to do at this point, and let me first of all direct you in the textbook. I've got a hard copy of the book in front of me, and there's a section on page 301 that is titled Multiple Linear Regression. And then if I turn the page to page 302, I'm looking at equation 8.11. Now, I don't know if the e-text is going to have this on page 302, but all you need to do is go into chapter 8 and then go to equation 8.11. And if you flip back a page after you find 8.11, that will be the point at which the reading starts with multiple linear regression. And at that point, what we're going to do here is understand that we have 6 independent variables. And so the model itself, when you look at the basic equation 8.11, it starts out with y hat. And the y hat means that the y hat value itself, once you do the math, is going to be the estimated, I think that's estimated earnings from the regression results. And so the equation, the form of the equation, very simply, if this was just simple linear regression and you only had one independent variable, it would just be the point or it would just be the portion where you have y hat equals b naught plus b1 x1, which again is just really kind of an algebra equation. It's a slope-intercept form of a linear equation. But in your case, since you have 6 independent variables, what you get is you get the intercept, which is b naught plus b1 x1, where the b1 values are the coefficients, I should say, and x1 through x6 are just the variables in the model. So this would be x1, x1, x2, x3, and so on and so forth, all the way down to x6. So the model in your case would be y hat would be b naught, which would be the value of the intercept, plus b1, so this value here times x1 plus b2 times this variable here, and then all the way out to x6. So the coefficient of x6 is this value times x6. So from just a basic model standpoint, it's going to look just like this, except you're going to substitute for all the b values. The x1 through x6 will stay because those are the variables in your model. So that would be the only thing you need left to do to finish up the golf problem. On this house problem, it looks like you've got all the regression results correct. And at this point, all you've got to do is you've got to use these results to estimate the price of a townhouse and a single family house, both I think with a lot cost of $30,000. So at this point, very simple. So if we want to do, let's say we want to do the townhouse estimate there, and we'll do the single family over here. Very simple. All you have to do is, using the idea of this basic form of the model in problem 2, is just go ahead and do the computations based on the results. So y hat would be equal to the intercept plus the coefficient of the lot cost times the actual lot cost, which is $30,000. Make sure I got the right number of zeros in there. Plus, so this is the townhouse model. So we're going to take this coefficient and we're going to multiply that by 1. So we are estimating the value of a townhouse. And then plus the interaction term times the cost of the lot, 30,000. And it looks like the estimated cost here. Let's blow this up. $163,277 would be the estimated cost of a townhouse. Now for the single family, equals, so y hat equals the intercept plus the coefficient times, again, the value of the lot cost, 30,000, plus, now in this case, since you have the coefficient, is this a townhouse or not? Since this is not a townhouse, we're going to say times 0, and then plus this coefficient times 0, again, because the interaction term for you was the lot, or was the townhouse times the lot cost. And then so we'll just add another 0 to the interaction term. And so let's see, what did I do wrong here? K by J times 0 plus K60. Let me do this one more time, Josh. Sorry about that. I must have put a bad value in here. So equals, let's see, the intercept plus this value times $30,000 plus the townhouse. I'm multiplying that by 0 because I'm coming up with the estimate for the single family house, and then plus the value of the interaction term. And again, since we're looking for a townhouse, that would be times 0, and hopefully that'll give us the right value. So 220,000. Make this a little bigger here. Make sure we got the right number of places. $220,288. So that is the estimate for the townhouse and the single family. The interesting thing to do if you really want to play around with this is go back and estimate this, where instead of having a townhouse in the model, you've got the single family house in the model, and you will come out with the same results. It doesn't matter how you treat the binary variable. So I hope this helps, and let me know if you have any questions.